On behalf of the Joachim Herz Stiftung, I would like to welcome you, and I'm more than happy that we're all here this afternoon to honor this year's winner of the Hamburger Preis for Theoretical Physics. And the winner is Professor Chris H. Greene from Purdue University, West Lafayette, in the US state of Indiana. Congratulations. The mission of our foundation today is to advance education, science, and research in the field of business administration, law, and the natural sciences. We support gifted and ambitious high school and university students, as well as promising researchers. We had the chance to support Professor Sengstock's cluster, Frontiers in Quantum Photon Science, and then became partners in LEXI, a state excellence initiative. The cluster itself sets the goal of combining outstanding research with outstanding work. In addition, the Hamburg Prize for Theoretical Physics was established in 2010 in order to attract top international researchers to Hamburg. Dear Professor Greene, you are probably aware that the Hamburg Prize for Theoretical Physics also means hard work. However, it will be fascinating and fulfilling. Your visits to Hamburg will serve to promote international networking and an exchange of information with the next generation of scientists and researchers. We are convinced that everyone involved will benefit from meetings and sessions with you, and some of these may even lead to long-term partnerships. Dear Professor Greene, congratulations again. The city of Hamburg will benefit from the fact that you, such a successful scientist, will share his knowledge with researchers here in Hamburg.
Thank you very much, Ms. Martin. Hello and welcome, everybody. Welcome to the awards ceremony of the Hamburg Prize for Theoretical Physics this year. It's my pleasure to be here. Yeah, I'm a science journalist. That's why they asked me to come here to break things down a little bit and make sure that everybody could understand it, even people who don't have a PhD in physics. There's one really neat thing about Rydberg-Molecules this year's prize is all about. The neat thing is that the basic concept is very, very simple. You simply take an atom and you blow it up as far as you can before it starts losing its outermost electron. And to do that, you basically tickle the atom with laser light. And by that, you get a very, very giant so-called Rydberg atom, which is much, much bigger than atoms usually get. It's of the dimensions of micrometers, and it's roughly 1,000 times bigger than atoms usually get. And the interesting thing now, if you have achieved that, you just bring another second normal-sized atom close to this giant Rydberg atom, and something very special can happen if you're lucky and if you know how to do it. The very big Rydberg atom and the tiny normal atom, they might actually feel attracted to each other. And if the attraction is strong enough, it's a bit like with humans, they might actually stick together for a while. And they will then form a molecule which has the size of a tiny virus, which is really huge. And it's, if I'm correct, by now the largest structure which has ever been built out of just 2 single atoms. And that's what we're talking about here today. Back in the year 2000, Professor Chris Greene here predicted the existence of these giant Rydberg molecules. And since 2008, we actually know that he was right, because back then they were, for the first time ever, observed, first produced, and then observed in a lab experiment at the University of Stuttgart. Professor Prof was just giving the last talk here, so he was involved in that. After having heard so much about this year's winner of the Hamburg Prize for Theoretical Physics, it's of course high time that we welcome him up here on the stage. Please join me, Professor Greene. I'm sure everybody's more than happy to welcome you here. The interesting thing, if you look at your CV again, is that you already have pretty strong ties to Germany. You also have German ancestors, but now you also have a German wife, right?
Yeah, that was one of the things I collected on my stay, and which was really nice that I could convince her to join the team. And yeah, I have ancestors going back to the 1850s. A professor, a great-great-grandfather was a professor in Marburg.
We've already heard that you're a brilliant theoretical physicist. So how did this come about?
When I saw the beauty of quantum mechanics, I was really drawn into the subject, and I thought it was just so incredible. I mean, here's a theory that's too weird to be on Monty Python, but it's true. And to have this deep truth to be so strange and interesting mathematics, it really had me hooked.
Back in the year 2000, when you wrote this paper together with two colleagues, and one of them is actually here, I think, did you back then realize how important this work is going to be?
It didn't really strike me as important. It wasn't the sort of thing you write when you propose for a grant and you have to predict your discoveries for the next 10 years. You know, it was just, wow, here's something kind of interesting. I didn't expect that. Let's look into this a little more deeply. And then you get talking with someone like Hossein Sadeghipour and the late Alan Dickinson, and it sort of snowballs, and you see it's just a fun project. And no, certainly it didn't seem particularly important, but it was really intriguing, and it's kind of fun to see it catch the imagination of others and now actually be realized by amazing experimentalists like Tillman Pfau.
What did you think when you heard from the University of Stuttgart that we've actually found the thing you've predicted to exist?
Well, actually, I was slightly nervous when this textbook cover appeared. You know, I was thinking, okay, they really seem to think this theory is right. It better be right. You know, I hope we didn't leave out any important physics in this. So it was a bit of a relief, I will admit. But we have a lot of confidence in our equations, and I had a great training from Ugo Fano and the heritage of Enrico Fermi that we were standing on, and gave me quite a bit of confidence that even if it had to be modified to some extent, the basic idea, that physics had to be there. I was pretty confident even before the experiment. Sorry, Tillman.
Is there any applications you could think of in the future? What is your answer? Is it just like basic fundamental science and nobody knows where it's going to lead to, or do you see any practical use of that?
Well, if you really take a stretch, you can imagine, you know, that these are manipulatable, if that's a word, I'm not sure, by very tiny electric fields, and you know, to be able to control the flow of information and matter with unbelievably small fields. Of course, it's a challenge to control the fields that well, but you could imagine it could have some implications, but I wouldn't bet the family farm on it.
Back in Boulder, where you spent 23 years, a long time, you were sitting right next to Eric Cornell, Nobel Prize in 2001 for Bose-Einstein condensation. You were also sitting right next to David Wineland at NIST, which is just across the street, basically, as far as I remember. Nobel Prize last year for fundamental works in quantum physics. So how important is it for you to have such brilliant experimenters around you? Is that of any use?
Well, it's very stimulating. I mean, I remember in the days shortly before Bose-Einstein condensation, and Carl would come into my office, Carl Wyman, and say, "What is this stuff about the scattering length?" And you know, and I could show him what I knew about it, and then to see that flower and blossom into a whole experimental, you know, tremendous accomplishment and Nobel Prize. It was really exciting to be involved in the early stages of all those discussions. It's a lot of fun, and it nudged me in the direction of cold atoms, where I've been it's been one of my main focuses ever since. So it's a two-way street. A beautiful thing about atomic, molecular, and optical physics, that experiment and theory are really closely connected this way. It's one of the truly, you know, most exciting things about this field.
What are you thinking of, and what projects might you be pursuing? What challenges do you want to tackle while being here in Hamburg?
Well, I've been really interested in pushing the toolkit, like John Bone mentioned, to be able to handle more and more complex situations. This toolkit started even when I was a PhD student and before, but where we could just do what now look like the most trivial of problems were such a struggle. And now we can you know, describe 4 atoms, 5 atoms simultaneously colliding and recombining, and to see where this goes, how to take the few body land into many body land and really understand the linkages, what aspects of a few particles, a few atoms interacting, or molecules carry over into the way you know, a chunk of metal behaves, or a superconductor, or a superfluid. This, to me, is one of the exciting challenges in the field, and we're trying to touch on that with our various methods and build our toolkit.
Would you think that we are soon going to see Rydberg molecules consisting of more than just 2 atoms?
Well, we already have. Tillman showed some in his talk.
Okay,
And
yeah.
we saw some, in fact, in the unpublished thesis work of my student at LSU, Ningyi Du. We were already talking about this possibility, although it seemed so remote, not even having seen the 2-atom molecule, that we didn't even publish these ideas at that time. But I think in principle you could, kind of the way Tillman was saying, you could grab molecules or atoms in all the lobes of these wave functions and really move them around, and could be an interesting area to explore.
Thank you very much, Professor Greene, for sharing your thoughts and some of your personal insights with us. Now, after talking so much, it's high time that we give you the prize you came here for. And the Hamburg Preis for Theoretical Physics has been established in 2010 to honor scientists for particularly great achievements in the field of quantum optics and laser physics. And it's going to be awarded by Mrs. Andrea Pauline Martin, who we've already met today, and also by Professor Senkstock. And I'd also like to ask State Secretary Pelican to join in the field, and maybe you sort out who's going to hand over whatever pieces we have to give to our laureate.